Hello, my dear students. So today we will discuss the topic on that is slope deflection method. So usually slope deflection method is used to analyze the continuous beam and frame structure. So in the today lecture, what we'll do? So we'll understand the basic concept of slope deflection method and fixed end movements and what are the steps to solve the so what is the procedure to use to solve the problems. Okay, so first thing is, if you want to solve the problems in slope deflection method, you need to understand the formula to calculate the slope deflection method. So if you are seeing in the diagram, there is a fixed beam is there. Okay, this is the fixed beam with UDL, the load is W. So if you want to calculate the what is the moment developed at point A and what is the moment developed at point B, this is the thing it is to be calculated. So again, you need to calculate what is the slope at A and what is the slope at B. So these are the things you need to be calculated for this beam. So how it is to be calculated? So for that one, if you want to calculate these fixed end movements, you want to calculate the movements and the slope. So what is the formula for that one is, so MAB is equal to MFAB means what is MFA? I will explain afterwards. Okay, the formula is MFAB plus 2EI by L into the bracket 2 theta A plus theta B minus 3 delta by L. This is the formula for this one. So how we are going to remember this formula? Just I will give a trick. So MAB. So MAB is equal to same thing you have to write, but it is with fixed end moment. That is MFAB plus 2EI by L into 2 theta A. Here first word is A. That should be multiplied 2. So that will be 2 theta A. Second word will be only that B. There is no multiplication of 2. So 2 theta A plus 2 theta B minus 3 delta by L. This is the formula for this one. Same thing. How you can write for MBA? So M for MBA, how will write? Like, can anyone tell me? So how we are going to write? But this one means MFBA. Same thing. What I am reading? MFBA plus. Can anyone tell me what it will come? So it is 2EI by L. 2EI by L into what? 2 times of first word. What it is B. So 2 theta B plus theta A minus 3 delta by L. This is the formula for MFBA. So this is the formula you have to remember. So if you want to solve the problems on slope deflection method, you need to understand this formula. Means you have to remember this formula. This is the one thing you have to remember. So I will tell the things what it is here. Theta A. What is the meaning of theta A? Theta A means theta A is the slope or rotation at point A. Theta A is the slope at point A. Same thing. Theta B means slope at point B. Okay. Slope or rotation. Same thing. What is the meaning of delta A? What is the meaning of delta A? Delta A means deflection or translation at point A. Same thing. Delta B means what? Deflection or translation at point B. So next one is MFBA. MFBA means what? MFAB. What do you mean of MFAB? MFAB means that is fixed end moment. MFAB means fixed end moment. Okay. So how we are going to calculate this one? I will tell you in just 2 minutes. Okay. So So once again I will repeat. Can you can also repeat. So MFAB is fixed end moment. Okay. The fixed end moment is going to vary. How it will be vary? Based on the loading. Based on the loading. So if you will see in this diagram, how the loading is there? The loading is UDL. Loading is UDL. For this UDL loading, so what is the fixed end moment? So for fixed end moment, for at A point will be, for this beam, MFAB value will be minus WL square by 12. This is the formula you should first remember. What is the formula for this one? For MFAB, the value will be minus WL square by L. How it is going to come? When there is a UDL, you are supposed to take MFAB is equal to minus WL square by 12. Same thing, if you come, this is the same beam. So for this one, can you tell me what is the formula for MFBA? What is the value of MFBA? So if it is for case, MFBA will be, here it is anti-clockwise and here it will be clockwise. That's why this will be plus WL square by 12. So what is the value means? If you see this one, MFAB will be WL square by 12. MFAB will be what? That will be WL square by 12 and MFBA will be plus WL square by 12. This is the thing you have to remember. Next is 2 EI by L. EI means what? That is flexural rigidity. EI means what? flexural rigidity. This is the thing you are supposed to remember. Means here E means Young's modulus, I means moment of inertia. So usually it is given in the question. Okay, E and I values to be given in the question, or combined value of EI is flexural rigidity. That should also given in the question. And L is what? L is the span of the beam. L is what? L is the span of the beam. So L means what? Which span you are supposed to take? Here, if you are seeing only one single beam is there. Here one single beam is there. If in the examination you will get the continuous beam. So this is A, B, C. So which span you are supposed to take? So if you see here, what you written here? MAB means here you are considering AB span. So that's why this L length should be taken as AB span length you are supposed to take. That is important what I am telling. So length will be of span AB you are supposed to take. Next one is theta A. So what is the meaning of theta A? Theta A means that is the rotation. That is the rotation or rotation at point A. That is a rotation or slope at point A. You have to remember this one. That is a slope at point A. So what is the slope at point A? If it is fixed end, if it is fixed end, slope will be equal to 0. If it is fixed end, the slope value will be equal to 0. If other than fixed support, so if it is a roller support, if it is hinge support, the theta value going to exist. It is not equal to 0. Whenever you will get the value of fixed, whenever there is a fixed, that at that point the theta value will be equal to 0. Here theta A is equal to 0 as well as theta B equal to 0. I think you are getting the things what I am telling to you. Okay. So once again I will repeat. What are the things here. We have to remember this formula. If you want to solve the problems on the slope deflection method, you have to mug up this formula. It's very, very important. It's simple also. Try to remember by trick. So what is that one? MAB is equal to MFAB. Same thing it is to be prepared with fixed end moment 2 EI by L into 2 times of first what you written joint A. That will be multiplied with 2 times of theta A plus theta B minus 3 delta by L. Okay. So next. Okay. So just now what I told. So here I told for the only fixed end. Okay. Here just now what I told the value of minus WL square by 12. It is only the thing is concerned with UDL. So in the examination, is not going to give the UDL. The loading will be different. Okay, there are for different loading cases. You are supposed to calculate where the different value of fixed end moment. So for that point of view, you need to remember the formulas. Okay, so I will brief out here. Okay, so first case, if you see here, what is the first case? So for first case, what is that one? The beam with UDL. Okay, and both are fixed. So for this case, what is the value of MFAB? So for the value for this beam, MFAB value is equal to minus WL square by 12 and MFBA value is equal to plus WL square by 12. Okay, so this is the thing you should remember. Next, for second case, whenever if the beam is given, with eccentric loading, okay, eccentric point loading means the load is not acting exactly at the center. For example, if it is at 3 meter and if it is at 4 meter, means the load is not exactly at the center. For this case, what is the formula? So formula will be M. The formula for this one is that is MFAB. The formula will be minus W. Please multiply this one. Means W first letter as it is, second letter second distance square. WAB square by L square. WAB square by L square. This is the formula you are supposed to do. For second case, MFBA, what happens? MFBA will be equal to plus WA square B by L square. WA square B by L square. This is the formula you're supposed to remember. Okay. So you have to remember the things by some tricks. So directly if you will mug up the things, it is very difficult. Okay. So how you have to solve this problem? Already this trick has been told in the class itself also. Okay. So you have, I think those who are attended, they are remember the tricks what I told in the lecture. So now you try to understand the things. Okay. Next for the third case, now the load is exactly at the center. Now the load is exactly at the center. If load is exactly at the center, MFAB value will be equal to minus WL by 8 and for MFBA value will be equal to plus WL by 8. Okay, so this is the thing you have to remember. Next formula. So next formula will be, so if the load is acting, 2-point load is acting at the same distance, means L by 3 distance. So what is the formula? So minus 2W by 12 minus 2WL by 9 for MFAB and for MFBA will be equal to 2WL by 9. So for in the class I given some tricks. Okay, always try to remember the formula by some tricks. Okay, so because why? Because if you are studying some structure subject, because you are having number of formulas, so all the formulas it is very difficult to remember. So you by seeing the diagram, you made some trick. So in the lecture, I will told some this trick of this, remember this formula. So what is the trick? This is the only trick. Okay, no, don't, there is no some scientific calculations. I have not done. Okay, only the trick. What is the trick I have given? So just I will tell you this one. So if you are seeing the video, you will get an idea. So here, how many loads are there? Two loads. So what I will write in here? 2 into W. Okay, total length is L divided by what I will write here. If you will see 3, 3, 3. What is the addition of this one? 9. 2WL by 9. This is my trick. So I have not seen anywhere. This is done by myself only to remember this formula. So you also try to remember this formula. If it is not comfortable, don't go for this trick. If you're okay, you can go for this one. So what is the formula for this one? So that is here two load. If it is at same distance, if it is some other distance, we are not supposed to go for this one. So what I told, two loads are there. 2 into W into L divided by 333 is 9. So this is for MFAB will be plus minus 2WL by 9, and for MFBA will be equal to 2W by 9. So next will be if the load is acting, UDL is acting at half span. So for that one is minus 11 WL square by 192, and for MFBA will be go plus 5 WL square by 192. Okay, this is the thing you are supposed to remember. Next, okay, it is already told. It is what is the application of this slope deflection method. Next, so what is the sign convention we are going to use? Okay, so what are the sign conventions are you using? If it is clockwise end movements are there, we will take positive. If it is anti-clockwise movement is there, we will supposed to take that is negative. So if we will see at joint B, so this is rotating clockwise. So if this is rotating clockwise, okay, so clockwise we will take positive and anti-clockwise we will take negative. So MBA, if you go for MBA, so how it is? It is clockwise. That's why it is taken positive. If same thing, if you go for MBC, how it is? It is anti-clockwise. That's why the value of that one will be negative. So consider this one. The clockwise movements are taken as positive and anti-clockwise movements are taken as negative. Same thing in case of rotations. Okay, so if you go for this one, if you read this one, clockwise rotations of a tangent to the elastic curve. Elastic curve means what? So elastic, so I will draw here elastic curve, so you'll get an idea. So this one, what you are seeing, this is the curve, deflected curve to the beam is called elastic curve. So for this curve, if I draw a tangent, for this curve, if I draw a tangent, okay, this is the tangent is drawn to this one. So here, how the theta with respect to this beam, this is the slope. Okay, this is the slope. How it is? It is anti-clockwise direction. With respect to this beam, the arrow mark is anti-clockwise direction. If it is clockwise, I will take positive. If it is anti-clockwise, I will take negative. So same thing I will take. If you see here, for this one first case, here how it is called clockwise or anti-clockwise at point A. You only tell me. So with respect to this beam, I am going toward the tangent. So if it is like that, so how it is rotating? It is clockwise. So that will theta A will be positive. Same thing if you come for at B point. So B point is like that. So this is theta 2. So theta T will be anti-clockwise. That is negative. Same thing for theta 3 is it positive or negative? So if you this is the tangent, I am going toward the tangent with respect to beam. So this will be from beam. Okay, from this beam. So this beam. So how it is rotating? It is anti-clockwise, right? That is negative. Same thing. This one, how it is from this to the tangent, so it is clockwise, so it is positive. Means theta 1 and theta 4 are positive, is it right? And theta 2 and theta 3 are negative. Okay, so clockwise rotations, we are supposed to, clockwise rotation of a tangent to elastic curve is taken as positive, and anti-clockwise rotations are taken as negative. I think you got an idea about this one. Okay, so next in, if you go for in slope deflection method, there will be the settlement of the beam is also given. The settlement of the supports are given. So for this case, you need to take plus sign or minus sign. Okay, when to take plus sign, when to take negative sign. So how means, so this is a beam. So this is the one beam. So if this in the question is given, B is sinks by 5 mm. So what is telling in the question? Support B is sinks by 5 mm or 10 mm, whatever it may be. This sinking of support is given. So if it is sinking down, so means what happened here? Here right support, Okay, if right support is sinking down with respect to left support, then we are about to take positive. Here it is written. The settlement delta is positive. When you are supposed to take positive, see here, delta value you are supposed to take positive. So when you are supposed to take positive means settlement delta is taken positive if right side support is below left support. This is left support. If right support is below the left support, then delta is taken as negative if left side support is below the right side support. When if you go for this one, for this case delta value will be negative, for this case delta value will be positive. Getting it? Once again I will repeat, when you consider this m for this AB span, delta value will be positive, for BC span delta value will be negative. If you see, read the statement, settlement delta is positive if right side support, this one, right side support, this one support below left side support. ये left side support से नीचे है ना, so that's why the delta is taken as negative. Okay, sorry, support positive, and delta is negative if left side support is negative. Once again I will read, you don't get confused. Don't get confused. Settlement delta is positive when you are supposed to take positive if right side support is below with respect to left support. This is the thing you have to remember. Don't get confused. Okay, next. So what are the procedures you are supposed to follow in order to solve the continuous beam? So first thing is you have to remember the formula. What is the thing is, first thing is you have to remember the formula. Can you tell me what is the formula? So I will write here. So what is the formula? So the formula is MAB. What is the formula for MAB? Can you repeat? What is the formula for MAB? Please. Okay. So formula will be, that is MFAB plus 2EI by L into the bracket. What is that one? 2 theta A plus theta B minus 3 delta by L. Minus 3 delta. This is the formula. So for that one, what is the step number 1? For each span continuous beam, we are supposed to calculate the fixed end moment. What is step number 1? We have to calculate the fixed end moment for each span. So if the beam is given like that, so this is the beam in the it is given in the question. So this is the support is given. So if it is center point load W is given, here it is UDL is given. So for this beam, we have to calculate the fixed end moment for each beam. Fixed end moment for each beam. So this is AB. Can you tell me what is the fixed end moment for AB? So MFAB, if center point load is there, what is the formula? That is minus WL by 8. Okay, MFAB will be minus WL by 8. MFAB क्या आएगा? Minus WL by 8. What about MFBA? MFBA will be plus WL by 8. Same thing if it is UDL. If it is UDL, what is the formula? For UDL, MFAB will be minus WL square by 12. Minus WL square by 12. And MFBA will be equal to plus WL square. This is the first thing what is supposed to do. So after that one, what is supposed to do? Means after that one, in second step, we are supposed to, in second step, what we are supposed to do means, in second step, we have to substitute the values, all the values in the main equation. Means in which equation? So this is the slope deflection. Means first thing is we have to calculate the fixed end moment for all the beams. Means we have to apply the slope deflection equation for all the beams. After that one, we are substitute that form fixed end moment in this equation. So all the values means theta A. So what is the value of theta A if it is fixed end? For fixed end, the value will be equal to 0. Same thing if in the question sinking of support is given. So if it is given, you have to take the value. If it is not given, directly you can put the value equal to 0. Okay. Next is EI value. If it is given, put it. Otherwise, as it is, you have to put the values. Okay. Next, L. What is the value of L? L is the span of the beam. Okay. So which beam you have considered. Next, after substituting, second thing is, first step is what? We have to calculate the fixed end moment for all the spans. Second step is what? In second step, we have to substitute all the values in the main equations. That is slope deflection equation. Next, what you are supposed to do? Next is we are going to for joint equilibrium. So what is the meaning of joint equilibrium? So this is the case. So if it is the beam, so this is the case. So this is A, B, C. So this is a point load and this is your joint equilibrium is what? Here I am going to apply the joint equilibrium. Here joint equilibrium, how can I write? that is MBA plus MBC is equal to 0. MBA plus MBC is equal to 0 means just now we are calculated the value of MBA. Get it? But what I'm telling, what we done already, we are calculated the value of MBA. Okay, that one you substitute here and we calculated the value of MBC. How we are getting MBA? MBA, what is the formula for MBA? MBA will be equal to, that is MFBA, MFAB, sorry, MFBA plus 2EI by L into the bracket of 2 theta B plus theta A minus theta W. That equation is substitute here, and same thing MBC equation is substitute here, and that should be equated to 0. That should be equated to 0. After solving this one, you will get some value, okay, and you will get EI theta B some value. You substitute in the equation, main equation, you will get the answer. Same thing if you'll see here, same thing is explained here. We will solve one problem, we'll get an idea. So this is the procedure, okay, what are the steps it is to be for this telling. Now you will not get proper idea. We will solve one problem also, we'll get an idea. Next is what on? You are supposed to solve the joint equilibrium. Just now what I told, substitute the value. Just now I told, substitute those unknowns in the main equation, and after that one, treating each member of the condition means after that one you substitute in main equation. Here if you substitute the values, finally you will get the value of all MAB and BA as well as theta A, theta B. This is the thing what we are going to discuss for introduction in the slope deflection method. Okay, so before concluding this session, just I will brief out what are the things we discussed. First we discussed, so what is the use of slope deflection? Slope deflection method is used to calculate to analyze the continuous beam and frames. This is the first thing what we discussed. After that one, slope deflection equation. Slope deflection, what is the equation? What is the slope deflection equation? The slope deflection equation is, that is MAB is equal to MFBA plus 2EI by L into 2 theta A plus theta B minus 3 delta by L. This is the formula. Okay. Next, after that one, that is the tabular column for fixed end movements. If it is fixed, WL square by 12. If it is center point load, that is WL by 8. If it is eccentric loading, then it is a WAB square by L square. If it is 2-point loading, 2WL by 9. Okay, so these are things you are supposed to remember it. And if it is fixed end, theta value will be equal to 0 for the rotation value. Next thing is, after that one, we studied the what are the sign convention. If it is clockwise, we are supposed to take positive. If it is anti-clockwise, we are supposed to take negative. Okay, next after that one, that is settlement. If what is the, how when you take positive, when you take negative, if with respect to right support, left support is sinking down, then we will take delta value will be positive. Next after that is procedure. What is the first step? First step is, in step number 1, what we'll do? For step number 1, we have to calculate the fixed end moment. This is step number 1. Step number 2, what is step number 2? In step number 2, substitute the value of fixed end moment in main equation. Next step number 3, solve the equation. Okay, after solving, you have to apply joint equilibrium. You will get the values, and again substitute in the main equation, you will get all the unknowns. Okay, this is the thing you are supposed to remember. Next, so apart from the table that is mentioned in the starting of the lecture, you have to remember these all formulas. You have to remember all. So this is already it is told. Same thing, this one is told, this is told. So this one you try to remember. Okay, so next is, so okay, the important thing I told, but this is also important. So this one you remember. If moment is exactly the center, so what is the value? M plus M by 4 and plus M by 4. Okay, if it is central triangular UDL triangular load is there, minus 5 by 96 WL square, and for MBA will be plus 5 by 96 WL square. Okay, it's triangular load. Okay, means 0 load at the end A and maximum load at B. So that will be minus WL square by 30 and plus WL square by 20. So don't expect only the things that is told in the last time it is to be asked. Some other loading is also given in the examinations. Okay, so these things also very important. Please don't miss these things. Okay, if you don't know fixed end moments, it is very difficult to solve the problem. So this way, this is also important. Try to remember. This is also important. Okay, so this one is also important. Okay, so this is also important. All are important. Okay, so probably these things you to remember. Okay, this is not required. Okay, as point of view. So but try to remember this is okay. It's very important, these things. Okay, they may ask these things. Okay, so thank you. If you have any difficulty, you can give a comment, so accordingly I will reply for this one. Thank you very much.